Hello all. I hope you all are in good health. Okay, so in college we were discussing about the different transport layer protocols. So those are TCP, UDP and SCTP. And we had started with the header of TCP, and we were briefly discussing about the different features of TCP. So in today's class, we will be elaborating those features. And for this one, I'm referring to book, that is, one is Data Communication by Furozen, and another one is Computer Networks by Tannenbaum. And the PPT is also made by referring those two, that is Data Communication by Furozen and Computer Networks by Tannenbaum. So out of the various features of TCP, one of the important feature is it provides connection-oriented service. So TCP, that is Transmission Control Protocol, is a connection-oriented protocol. Okay, so which means that the two process, okay, if they want to perform the data transmission, then they will have to establish connection. Then from that connection, they will be sending all their data. And once data transmission is over, they will have to terminate the connection. So what exactly is the connection? So a connection is nothing but a virtual path. Okay, it is not a physical path. So physical path is the network, the physical link, okay, from where the data will be transmitted, and this will be taken. The communication over the physical path will be taken care by the IP, which is one of the important protocol of network layer. Now above IP, we have a TCP. Okay, so TCP is going to create the virtual link between the sender and the receiver. And from that virtual path, all the data transmission is going to take place. Okay, now this connection-oriented transmission takes place in three phases. The first one is called connection establishment. Okay, once it is done, then the second phase is data transmission, and once all the data is transmitted, the connection will be terminated. Now moving ahead, now when the two processes are going to communicate, okay, so data can be transferred in any of the direction. Okay, so both the process can transmit the data. So that is why the TCP data transmission takes place in full duplex mode. So full duplex means in both the direction the data transmission can take place. Now for that, the connection establishment means the process which wants to communicate data with another process, okay, is informing the other process that it is going to transmit the data and be ready, okay, to receive the data, okay, and to ensure that you have all the resources available with you to store the data that I'm going to send. For example, in this case, let us say A wants to send the data to B. So A will be informing B that it wants to create a connection, and from that connection, it is going to transmit all the data. Okay. Now for that, the figure that has been shown is the simplest scenario, wherein A is sending a packet called connection request to B, and in response to that, B is sending connection grant. So once A gets the grant from B, it has started data transmission to B. So this is the simplest form of connection establishment, but the simplest form has many problems. Okay, the problem is, because of this scenario, you can see in the figure that, let us say, process A, this is, let us say this is process A and this is process B. So process A, once it establishes a connection, okay, it is going to inform process B to transfer some amount to account X. Okay, so transfer 20 lakh to account X. So for that, it sent a connection request. Once connection is granted, it is sending the data. Okay, that is to transfer the money to some account X. Now, here the communication which is taking place between two processes, it is going through a network which is unreliable. Okay, remember that network is not reliable. It just provides best effort delivery. Okay, that is, it tries its best to deliver the data to the receiver, okay, on time. But it may so happen that the network is because it is having many different paths, so network is creating duplicate copy, and different copy is getting transmitted through different link. okay? And let us say there are other copy of the same connection request which is there in the network, and it got delivered to the receiver after some time, okay, after some delay, because the network is not reliable. Now in that case, what will happen is the receiver will think that this is new connection request, and for that it will be sending a connection grant, okay? Now here the sender does not know why it is receiving the connection grant, okay? And the data packet also the receiver is receiving after some time, okay? So again here the data is also a duplicate packet. Now for that, the process B got the connection request. In response to that, okay, which was duplicate actually, so in response to that it sent connection grant, and again it is receiving the data, okay? So it is satisfying the requirement for transferring 20 lakh to account X. So what process B will do, it will execute this transaction of transmitting 20 lakh to account X, which is wrong, okay? Now this, why this problem happened was because one thing is the second time when the process B is receiving the duplicate connection request, okay, it had to again confirm from the sender, that is from process A, okay? If it had confirmed from process A, then this problem wouldn't have had happened, okay? Another one is, suppose there was some number that was associated with the connection request. Let us say every connection request is numbered. This is number 1, and this is, let us say if it is getting that duplicate request, its number is also going to be same, okay? Now if that was there, then also the process B would have been able to identify that this is a duplicate connection request, and for that it would have discarded that connection request, okay? So for that, the TCP, previously they had used only these two techniques, so sending connection request and connection grant, okay? But they started getting this problem, okay, because of duplicate connection request and because of duplicate data, okay? There was false transaction that was happening in the network. So for that, TCP started using this another technique, wherein if we go back to the previous figure, then process B, okay, before conforming the connection, okay, before assuming that the connection is established, it is going to again confirm from the process A, okay? And every connection request, every confirmation, okay, every acknowledgement is going to have some, is going to be identified uniquely, okay? So every packet, the connection request packet is going to have some number, okay? So we will see this thing here, that as I said, TCP uses for the connection establishment, they uses three-way handshaking technique, okay? So that means before client and server, before confirming that the connection has been established, they are going to perform the three-way handshaking, okay? So for that, here the client will be sending a connection request packet. Here this is called synchronization packet. So client is sending a synchronization packet to the server. So client is informing server that it is going to establish a connection with server, and it is asking for the confirmation, okay, whether the server is going to accept the request from the client or not, because server will have to accept the data and it will have to process the request that the client further will be sending. So for that, client is sending a synchronization packet to the server, and server, synchronization packet means client is trying to establish the connection, okay? So in response to that, if server is in a state of accepting the client's connection request, then server will again be confirming the client by sending another synchronization packet, as well as server will be sending acknowledgement to the synchronization packet which it has received from the client. So here server is receiving a synchronization packet. Now this synchronization packet, for this one, server will be sending the acknowledgement, as well as server will be sending its own synchronization. Okay, that is, again the server is asking whether you really want to create the connection with me or not. Okay, now what happened till now is client sent a synchronization packet to the server, and for this synchronization packet, server is sending the acknowledgement Okay, and server is again sending another synchronization packet to the client, and in response to that, client will be sending the acknowledgement. Okay, so server is confirming, so client is saying, yes, I'm actually trying to establish the connection with you. So once server receives this acknowledgement, server will be sure that the connection request was the fresh one and it is not the duplicate one. So once this connection is established, the data transmission will take place. So why this is called three-way handshaking is, before actual data transmission, 3 times communication took place. Okay, so the first time was client is sending synchronization packet to the server. In the second time, server is again confirming and sending the acknowledgement, and which means it is sending synchronization packet with the acknowledgement. And in the third communication is client is sending acknowledgement packet for the synchronization packet of the server. Okay, now the next important thing here is the numbering. Now the first packet, the synchronization packet which client will be sending to the server, it is going to have a sequence number because it needs to be uniquely identified, this packet. Okay, so one sequence number will be consumed by this synchronization packet. Now when server will be sending the second synchronization packet, okay, along with the acknowledgement, here server need not be sending 2 different packet, one for synchronization, one for acknowledgement. Okay, server can use the piggybacking technique wherein acknowledgement can be sent with the synchronization packet itself. Okay, if you remember the TCP header, you have both the data section as well as the acknowledgement number field. Okay, so you can send both data as well as the acknowledgement. So here server will be sending its own synchronization packet, okay, so which is going to contain a sequence number, so that also needs to be uniquely identified by the client. So this synchronization packet is going to have a sequence number, and server is going to send the acknowledgement to the previous synchronization packet. Okay, so we had discussed about this in class that acknowledgement number will be 1 greater than the sequence number of the byte, okay, that's the process just received. That is, let us say server received sequence number X and server is now expecting to receive another packet, okay, which will have the sequence number X plus 1, then its acknowledgement number will be X plus 1. So for this synchronization packet, whose sequence number is X, server is sending an acknowledgement with a number, that acknowledgement number that is X plus 1. Okay, which means that this is the acknowledgement for this synchronization packet. Now server is again, as with this one, server is also sending this synchronization packet which has some sequence number that is Y. Now for this synchronization packet, client is sending an acknowledgement. Okay, so how this acknowledgement will be identified? By the number. So number is just Y plus 1. So server is now expecting to receive Y plus 1, which has 2 meaning. Okay, one is client now is expecting to receive Y plus 1, as well as client is acknowledging that the packet, okay, with sequence number Y, it received successfully. Now, once it is done, all the data transmission is going to take place. Now, this acknowledgement packet need not have any sequence number, okay, but if it is carrying data, so client can send acknowledgement as well as the data to the server. So if it is carrying the data, then it is going to contain the sequence number. Otherwise, acknowledgement packet will not have any sequence number. Now, let us see this example. The same three-way handshaking has been shown here with a packet. Now, what are the important field in the TCP header? Okay, for the connection establishment, okay, for or during synchronization are the sequence number and sync flag. This is a sync flag, and the acknowledgement flag and the acknowledgement number. Okay, so you can see here these are only the important field in the TCP header. Okay, which is important for the connection establishment. So only that has been shown here. Now, as we had discussed in lab, that the server will have to, first of all, be in ready mode, okay, to receive the connection request from client. So for that, Okay, server will be executing the socket function, then bind function, then listen function. So once server executes the listen function, it is said to be in passive open state. Okay, so server is now open or ready to accept the connection request from client, but it is in passive mode. Okay, it has not received any connection request. Now, always the connection will be initiated by the client. Okay, now the client will be sending a synchronization packet to the server. Okay, once it sends the synchronization packet to the server, client will be said to be in active open mode. Now for the synchronization packet, as I already said, server will be sending the acknowledgement for the synchronization, and then it will be sending its own synchronization to the client. For this synchronization packet, server will be sending acknowledgement back. Sorry, client will be sending acknowledgement back to the server. Now the important thing here is to see the sequence number and the acknowledgement number field. Okay, so this is a synchronization packet. So synchronization packet will be identified by using the flag, that is sync flag. So if the sync flag is set, it means this packet is a synchronization packet. Okay, now this synchronization packet is going to have a sequence number. Okay, so this synchronization packet will be uniquely identified by using this sequence number. So let us say client is sending a synchronization packet with sequence number 8000. So for that, server will have to send acknowledgement. So this acknowledgement is going to have number 8001. Okay, which means that it is saying server is saying client that it received a packet with sequence number 8000 successfully. Okay, now with this one, server is also sending a synchronization information. So here in this packet, the acknowledgement field for this acknowledgement number is set, and sync field is also set because this is also a synchronization packet. Now this synchronization packet has this sequence number 15,000. Okay, now when the client will be receiving, it will be sending the acknowledgement to the server, and in the acknowledgement, okay, it is informing that client is informing that it received a packet, okay, with sequence number 15,000 successfully. Okay, which means acknowledgement number is 15,001. Now you can see here, this is only a acknowledgement packet. Okay, it is not a synchronization packet, so only acknowledgement field is set. Okay, now this is not carrying any sequence number. You can see here the previously sent packet sequence number was 8000. Now this packet sequence number is also 8000. So it is not using any sequence number. This is just the old sequence number. Okay, but other two packet, the first packet and the second packet, they used a new sequence number. So some of the points to remember here is the synchronization segment, even though it does not carry any data, but it consumes one sequence number. Similarly, synchronization plus ACK segment, okay, does not carry any data, but again it consumes one sequence number. But the ACK segment, which is the last segment, does not carry any sequence number if it is not carrying any data. But as I had said earlier, that when the client will be sending this acknowledgement, it may also decide to send the data. Okay, so when it is sending the data, then it is going to consume the sequence number. Otherwise, this acknowledgement packet will not consume any sequence number. Now there are some there are some cases, not problem exactly. There are some cases that may happen in the connection establishment phase. Okay, that is, what if both the process simultaneously try to establish the connection? Okay, so that means in that case, process A as well as B will simultaneously be sending a synchronization packet. Okay, but this will not have any problem because you can see here, A is sending a synchronization packet with sequence number J, B is also sending a synchronization packet with sequence number K. So for that, both the party, they are sending the acknowledgement along with their own sequence number, and both the party, they are sending the acknowledgement to each other. Okay, at the end, it's the same connection that will be established between the two parties. Okay, So simultaneous open will not create any problem. But there is one problem that can occur, okay, during the connection establishment phase, okay, because of this three-way handshaking in TCP, and that is called Syn Flooding Attack. Okay, this is one type of denial of service attack that may happen in the network, and that is this problem will occur. So when attacker is sending large number of synchronization packet to the server, let us say, okay. So server, after receiving every synchronization packet, what it does is that it will be reserving some resources, okay, that will be required for that client, okay, and it will be sending sync plus ACK packet, and it will be waiting to receive the ACK from the client, okay. Now, if the attacker this way, if it is sending large number of synchronization packet, then server will be reserving the memory or the other different resources for each synchronization packet, okay, and for each synchronization packet it will be sending the acknowledgement. Now with this one, what will happen is, because of this large synchronization packet, okay, server is reserving its resources, so ultimately server will go out of the resources, okay, and server will crash. Now this is happening because server is getting large number of synchronization packet from the attacker node, wherein in each synchronization packet attacker will be giving the different IP address, isn't it? So for that, server is sending sync plus ACK, which is going nowhere because that IP address which was there in the packet itself is wrong. Now this is one type of problem called denial of service attack. So wherein because the server is running out of the resources, after that if server gets any connection request from the authenticate user, then server will not be able to give the grant to that user, isn't it? Because server does not have now enough resources, okay, to handle the remaining clients. So this is like a server is capable of providing services, but because of the malicious node or the attacker node, server is not in position to provide services to the client, okay, to the actual authenticate user. So this is called Syn Flooding Attack. There are various solutions that has been given to deal with this. One of them is to limit the number of synchronization packets, okay, for a time period. Okay, let us say server will not be accepting more than, let us say, 100 number of packet. Okay, that is one solution. Another solution is not to reserve the resources, okay, until the entire communication does not gets complete. Okay, this is what is being used in SATP, wherein server will be using cookie. Okay, so temporarily the resources allocation will be done to the one, okay, from whom it will be receiving the synchronization packet. Now once the connection is established, then the physical resources will be allotted. So use of cookie, the main reason is to avoid this Syn Flooding Attack, okay, which has been used in SCTP. Now, as I said that once the connection is established, the data transmission will take place, okay. Now, how the data transmission takes place? This is one important thing that we need to know about the numbering, okay. So as I said, every packet is going to be uniquely identified by the sequence number, okay. Here, when we are using TCP, every packet is called segment, okay. Now, every segment will have a sequence number. Now, when this server will be receiving the data from the client, it will be sending the acknowledgement back to the client. Acknowledgement packet is also going to contain a number. Okay, that number is the sequence number which the other process is expecting to receive next. Okay, now let us see this using this example. Let us say client is sending the data, and data is having stream of bytes, and the first byte number is 8001 and the last bytes number is 9000. Okay, so in this one it is sending 1000 byte of data. So sequence number is the number of first byte of the data. So sequence number is 8001 because the first byte of this data number is 8001. Okay, and let us say this client had already received some packet from the server, for which server okay, client is sending the acknowledgement for that also. So this is a piggybacking that is happening here. So client is sending acknowledgement also for the sequence number which sorry, for the packet which client received previously. Okay, now this sequence number, as I already said, this is 8001, which is the number of the first byte in this packet. Okay, and it is also sending the acknowledgement which is 15001. So for that, if the acknowledgement flag is set. Okay, now this is sending to the server. Now client is again sending another packet to the server with sequence number 9001 because previously it had sent from 8001 to 9000. Now it is sending from 9001 to 10,000. So its sequence number is 9001. And again it is receiving, expecting to receive 15,001 from server. Okay. Now once server receives these two packet, okay, it is sending acknowledgement. Okay, now it is not server for the other process, it is not necessary to send acknowledgement for each packet. Okay, it may wait to receive some segment, some set of segments, and then only it can send the acknowledgement. This type of acknowledgement is called cumulative acknowledgement. Okay, so as a whole, all the segment which it received, okay, in this entire duration, for all the segment it is sending one acknowledgement. Okay, now here the acknowledgement number is the next byte, okay, number of next byte that the server is expecting to receive next. So server received byte number 10,000 successfully. Now the server is expecting to receive 10,001. Okay, so server is sending this acknowledgement packet. With this one, server is also sending the data. So previously client was asking server to send packet with number 15,001. So server is sending 15,001 to 17,000. Okay, in this packet. Now for this one, client is sending the acknowledgement. So acknowledgement number is going to contain 7,001 as a number. Okay, again let us say it does not want to send any data, so it is not using any sequence number. Okay, or now you can see here there are some of the there are one more flag that was set, okay, in this example, that this is called push flag. P here is push flag. Okay, so push flag is used whenever the two process, they are communicating some data, okay, which has to be given to application process as soon as possible in the receiving side. And in the sender side, suppose sender TCP is receiving data from the application program, okay, and application program is asking that TCP to push, okay, which means that it needs to transmit that data as soon as possible. Okay, so in the sending side, the meaning of push is whatever data byte it is receiving from the application layer, for that data byte, it will have to create the segment, okay, as soon as possible. That means it need not be waiting for the and all the segment, okay, which means that let us say the capacity of one segment is 10,000 byte. Okay, now it is receiving, the sender TCP is receiving, let us say 200 byte from the application program with push information, which means that the sender TCP should not be waiting to receive all 10,000 byte. Okay, with this 2,000 byte only, it can create a segment and it will have to transmit that segment. Now similarly in the receiving side, okay, if it is receiving a packet with push flag set, it means that it will have to just so it will have, if it is receiving a packet with push flag set, it means that it will have to deliver that bytes, okay, whatever it is receiving in that segment as soon as possible to the receiver TCP application program. Okay, so receiver TCP will be having a buffer. It should not be storing that bytes in the buffer and wait until it turns come to be forwarded to the application program. Okay, as in when it receives, it should be forwarding that data packet to the application program. Okay, so continuing with that, I had discussed about this push flag. There is one more flag, that is urgent flag. Okay, suppose if the urgent flag was set, then the meaning is, suppose the application program is sending some set of bytes, okay, to the sender TCP, and it is saying that this set of bytes are urgent. Okay, which means that the sender TCP will be storing those bytes in the beginning of the segment, okay, that it will be creating to transmit next. Okay, and in the receiving side, okay, if it is receiving any segment, okay, with urgent bit set, it means that the urgent pointer is going to give information about uh, the the bytes, okay, that is starting from first byte to how many bytes, okay, are the urgent bytes. And the meaning of urgent byte is, in that segment, okay, how many bytes are set urgent, okay, those bytes has to be delivered to the application program, okay, first by the receiving TCP, which means that in the receiving side, receiver should not be waiting, okay, for for its turn to come, which means that those bytes needs to be considered first and it has to be delivered to the application program, so that like for example, a client has transmitted some set of bytes, okay, to process in the server. For that, server send the reply. Now once client got the reply, okay, it found out that those set of byte which client is sending to server is having some mistake, so server should not be processing that. Okay, now if client sends abort request to server, then that abort request in the server's buffer, it will be stored at the end, okay, which means that whatever data the server had received previously, it will be processing that data, and at the end it will be executing the abort request. Okay, now to deal with this kind of problem, what the client process can do is it can set urgent flag bit. Okay, with that, server will consider, okay, that data as urgent, and it will be giving that data byte to the application program first. Okay, and those data byte in that particular segment, okay, client will be sending the bytes in segment by segment. So in that particular segment, those urgent data byte will be stored in the beginning in the data section. Okay, now moving ahead, the last phase is your connection termination. So once all the data transmission is done, any of the process can initiate the connection termination. Okay, usually it will be initiated by the client, but server can also initiate the connection termination. Okay, now connection termination can be done by using two techniques. Okay, any one of the two techniques. The first one is called three-way handshaking. The second one is four-way handshaking with half close option. Okay, now this is a famous problem called two army problem, okay, that occurs during the connection termination. Now, in this problem, let us say, just see the diagram. Here, there are two types of army. Okay, one is called blue army, the other one is called white army. So there are four blue army. Okay, two in one side, two in the other side, and there are three white army. Okay, now suppose blue army wants to attack white army. Okay, so if blue army group 1, okay, attacked white army, then there are only two people, so there are three, and there are three white army, so three white army is going to kill those two blue army. Okay, now if blue army group number 2 goes to attack white army, again the same problem. There are only 2 person here, but there are 3 person here, so blue army will be killed by white army. Okay, now if blue army want to kill white army, okay, if blue army want to attack white army, then the only solution is blue army group 1 as well as blue army group 2, they both will have to attack white army simultaneously. Okay, because with that one the count of blue army will be 4, 2 in one side, 2 in the other side, and the count of white army is only 3, so blue army will be able to defeat white army. Okay, now the problem here is between these two group of blue army, in between you have a valley, okay, wherein there is white army. Okay, so blue army group 1 and group 2, they are, for them to attack simultaneously to the white army, they need to decide on the time. Okay, so when they are going to attack, so for that they will have to communicate with each other. Okay, let us say blue army wants to let us say blue army is sending a message to this blue army that it wants to attack at some time, let us say at 9 a.m. okay, tomorrow at 9 a.m. Now this message this group 2 should receive, okay, and it will have to acknowledge this group 1, and once both of them come to same time, okay, conclusion about the same time, then both of them can start attacking. Okay, now the crucial part here is how they will be communicating this message. Okay, so there will be some messenger who will go via the area wherein there is a white army. Now this white army can intercept the message, okay, or can keep that message with themselves. They may not forward the message to blue army. Let us say this blue army 1 is saying that let us attack tomorrow at 9 a.m. okay, and this message white army is keeping with them. Okay, it is not forwarding to the second group. In that case, if blue army goes to attack, then they will be dead. Okay, similarly, let us say blue army is not going to attack until it does not receive acknowledgement. Okay, so for that, let us say it sent a message and this number 2 also sent the acknowledgement. Okay, but acknowledgement is intercepted by, let us say, white army kept the acknowledgement with them. Okay, in that case, what will happen is blue army 1 will not be attacking, but blue army 2 will attack because it has got a message and it has sent the acknowledgement also. So if this blue army 2 goes to attack this white army, then they will be dead. Okay, they will be killed by the white army. Now what needs to be done is the blue army 1 will be sending a time to blue army 2. For that it will be sending the acknowledgement. Now for this acknowledgement also blue army 2 should be receiving the acknowledgement from blue army 1 that it received the acknowledgement. Okay, so if this one receives the acknowledgement, it may go to attack the white army. Okay, now this is a problem which cannot be solved completely, but up to some extent it can be solved. Okay, so that has been done by using this three-way handshaking. So wherein blue army will be sending a time to the group 1 will be sending a time to group 2, and group 2 will be sending the acknowledgement, as well as group 2 will be sending a confirmation. Okay, so it is saying that okay, tomorrow at 9 a.m. sure, no? So for that blue army 1 will be sending the acknowledgement. So once this entire process is done, then only the termination will be done about the connection. Okay, now as I said that there are two ways of connection termination, either by using three-way handshaking or by using four-way handshaking with half close. Okay, so three-way handshaking will be terminating connection in both sides. Okay, any one of the two process can initiate the connection termination, but once this three-way handshaking is done, both the parties connection is done. So neither client will be able to send the data to the server, nor server will be able to send the data to the client. Okay, this is how three-way handshaking will be working. So for that, client process okay, will be the usually it will be the client who will be terminating the connection. So client will be sending a packet, okay, final packet, wherein fin flag will be set in that packet, and it is going to consume one sequence number. So this fin packet will also be uniquely identified in the network by using this sequence number. Okay, with this one, it may also send the acknowledgement of the previously received data. Just remember that before this connection termination, what was happening was data transmission was going on between client and the server. Okay, so in response to the data transmission, client can send this acknowledgement, as well as if it wants to terminate the connection, it can send the finalized packet, okay, with fin flag set with one sequence number. Now for this one, server, for this fin packet, server will be sending the acknowledgement. So that means if sequence number is X, then its acknowledgement is going to contain a number X plus 1. And again, it is sending a fin packet. So fin plus ECK in one packet. Piggybacking has been done here. So for this fin packet, the client will be sending the acknowledgement with the number Y plus 1. Acknowledgement number is Y plus 1 here, because the sequence number in the fin packet was Y. Okay. So with this three communication, once it is done, the connection will be terminated. Now fin packet, the first packet is consuming one sequence number. The second packet is also consuming one sequence number, but the third packet, that is acknowledgement, does not consume any sequence number. Now the second type of okay, so there was, I think the slide was paused. Okay, so whatever I was discussing, it was from all this slide, if you can see. Okay. Second type of connection termination technique is four-way handshaking with half close. Okay, so this will be done if, like, if from one direction the process does not want to further send any data. So suppose if the process wants to terminate the connection only from one side, okay, that then it can use this four-way handshaking with half close technique. Okay, for example, let us see in this case, client is terminating the connection. Okay, so client, from its side only, that it does not have any further data to transmit to server, so it is ending the connection. So it's outbound connection, it is terminating. So for that, it is sending a finalized packet, okay, with fin flag set with one sequence number. Now the server, okay, suppose if it has data to transmit to the client, okay, server has received some data from the client which it is currently processing, and after some time the result of that processing, server needs to send to the client. Okay, so if it is going to send data in the later part, then it cannot send finalized packet to the client, because that is going to terminate the connection. So for that, server will be sending the only the acknowledgement for this finalized packet, which means that the communication from client to server is cannot happen further. So that means data cannot be sent from client to server, but from server to client, data can be transmitted. Okay, so after that, let us say server is sending data to the client, for which client is sending acknowledgement, and once all the data is transmitted by server to client, server will be closing the connection using the fin packet with one sequence number, and for that, client is sending a acknowledgement number. So if the sequence number is Z, as I already said, acknowledgement number is Z plus 1. Okay. So this is four-way handshaking using half close. Now this is briefly about the TCP state diagram. You can see here the blue one is for the server, the red one is for the client, and the dotted arrow is only the unusual event, okay, like reset, okay, finalize acknowledgement, or some kind of event has been shown by the dotted line. Now initially both server and the client will be in the closed mode. Okay, now server will be listening, will be ready to listen for the synchronization request from the client. If server receives the synchronization request, okay, it will be sending the acknowledgement and connection is established. Okay, so here this client is sending the synchronization packet to the server, synchronization sent. Okay, once it receives the acknowledgement from the server, the connection has been established. Now once connection is established, the data transmission will take place. So sliding window protocol will be used in the data transmission here. And once all the data transmission is done, then either server or the client can initiate the connection termination phase. Okay, so let us say client is sending the fin packet. Okay, so it is waiting to receive the acknowledgement for the server. So once it receives the acknowledgement, then the connection is terminated in both the side. Okay, so after this, we will be discussing about the sliding window. Okay, how the data transmission takes place in TCP. So I will be ending this video. Okay, so we will again be starting with the another topic.